નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી.
Hello students, today we will study the question number 9 of exercise 6.2. This is the topic of standard 10 chapter number 6 triangles. So what is the question? Question is ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at point O. So that AO upon BO is equals to CO upon DO. So here we do not have given the diagram, but we have given that it is a trapezium. So we can draw the trapezium ABCD, in which we have given that AB side is parallel to CD side, right? Like one of the pair of a trapezium is parallel to each other. And if we draw the diagonals AC and BD, then they are intersecting in a point, and that point is O. So if this is the required diagram, then what we have to show? We have to show that AO upon BO is equals to CO upon DO. Right? That we have to show here. So see, till now whatever we have studied about, that is about the triangle. Right? So if there is two parallel lines we can find out in a triangle, then only we can apply the theorem 6.1. So here if we consider the triangle ADC, then this DC if we consider as a base, then we required one of the line that must be parallel to this DC. Or if we consider this triangle ADB and AB is the base, then again we required one of the line that is parallel to this side AB. Okay, if we consider this diagram BDC, then also we require one line that is parallel to this base DC. And if we consider the triangle ABC, then we require, if we consider AB as a base, then we require one of the side that is parallel to this AB. In short, we have to make one of the construction here. That construction must be either parallel to DC or parallel to AB. Understand? Okay. Now let us draw one of the line that is pass through this O and give it the name M. Right? Give it the name M. So what we do here? We draw a line that is OM, and OM is, let's suppose, parallel to AB. OM is parallel to AB. And you see that AB is already parallel to CD. That means we can write down, therefore CD is also parallel to OM. So now here this OM, AB and DC, all the three are parallel to each other. Now if we consider here one of the triangle ADC, right? Then in triangle ADC, MO is parallel to DC. That we have to require. And now we can apply the theorem 6.1. So in triangle ADC, MO is parallel to DC. So according to the theorem 6.1, here we can write down that AM upon MD is equals to AO upon OC. AO upon OC. Right? According to the theorem 6.1. Give it the equation number 1. Okay. Now you may think that what will happen if we draw the total line instead of MO? Can we draw the line which from this point, this side to this side? Yes, we can also do this, but there is no requirement to draw the total line, because here we consider one of the triangle ADC, in which what the two things we require is AO and BO. AO and BO. But here we get the two things, that is AO and OC. AO and OC. Two things we can get from this triangle. Now if we consider this triangle ADB or DAB, if we consider this triangle DAB, Which two sides we get here is OB and OD. OB and OD. So here we get the two sides AO and OC. If we consider this triangle DAB, we get the two sides DO and BO. Then by comparing, we can find out the answer. That is why there is no required to draw the line from this side to this side. Okay. Now consider this triangle DAB. So in triangle DAB, right? DAB, MO is parallel to AB. MO is parallel to AB. Right? Now according to the theorem, this we can write down that dm upon ma, dm or md, md upon am is equals to OD upon OB, OD upon OB. Okay, we have just write down this MD instead of DM because we want to compare it with this thing, right? So MD and DM will be equal. In the same way, AM and MA are also equal. So here we just write down in this way, so it is easy to compare. Now this is also according to the theorem 6.1. Give it the equation number 2. Now compare equation number 1. Okay, before we compare here, you can see that if we want to compare these two things, here AM is in the numerator but here AM is in the denominator. So before we compare this, what we have to do here is we have to write down this numerator as a denominator. In the same way here also. So here we can write down AM upon MD is equals to OB upon OD. Give it the equation number 3. Now compare the equation number. Compare equation number 1 and 3. Right? Compare these two equations. Now we can see that left hand side is the equal. So right hand side also will be the equal. So AO upon OC is equals to OB upon OD. But here what we required? AO upon BO. AO upon BO. So we can take this to left hand side here. It will go in the denominator, and by taking this OC, it will go in the numerator with the OD. So here we get, here also we can write down it as a AO upon BO is equals to CO upon BO. And this is what? This is the required result that we have to solve. Right? Okay. So simple this thing we have to just write, we have to just construct this MO line which is parallel to DC and AB. Right? Okay. In the same way now let us study the question number 10. Question number 10 is the diagonals of a quadrilateral ABCD intersect each other at point O such that AO upon BO is equals to CO upon DO, so that ABCD is a trapezium. So see, this sum is like the converse. This sum is like the converse of this sum, because in this sum we have given that ABCD is a trapezium and this thing we have to prove. While in this sum, this thing we have given, and what we have to show? That the ABCD is a trapezium, right? So here the reverse process we have to do here, right? So here also to apply either theorem 6.1 or to theorem 6.2, we must have the two lines which are parallel in a triangle. So here also we will draw one of the line MO, right, which intersect AD at a point M. So here now we have drawn that MO is parallel to AB, right? MO is parallel to, let's suppose not AB, let us take BC. Okay, now in the same way, like here we have considered one of the triangle ADC, here also we can consider triangle ABC. So in triangle ADC, MO is parallel to BC. So according to the theorem 6.1, what we can write down, that AM upon MD is equals to AO upon CO, right? AO upon CO according to the theorem 6.1. Give it the equation number 1. Now, here you may think that now we have to consider another triangle, that is DAB. No, here we do not have to consider another triangle. We have to use the given, whatever we have given. Here we have given AO upon BO is equals to CO upon DO. So, here we cannot directly, if we want to compare these two things, we cannot directly compare this. So, what we have to do? We have to write down the same thing first of all here, that is AO upon BO is equals to CO upon DO. Now see, here AO upon CO is there. So we have to take this CO to the denominator here. So by doing this, we get AO upon CO is equals to BO upon DO. Now give it the equation number 2. Now when we compare, we can compare both this equation. So from equation number 1 and equation number 2. Now when we compare both this equation, see this AO upon CO, here also there is AO upon CO. So this AM upon MD will become equal to BO upon BO. Now what is this we get? We get the ratio, for which here we get AM upon MD is equals to DO upon BO upon DO, right? So AM upon MD is equals to BO upon DO. But here if we interchange this, see this AM and MD and DB and BO and DO we have, but from this we cannot make one of the, we cannot consider one of the triangle. So here we have to again interchange it. So we can write down it as a MD upon AM or DM upon AM. DM upon AM is equals to DO upon BO upon BO. Now see, DM upon AM is equals to DO upon OB. So what this is, we can consider now triangle ADAC. So in triangle DAC, one of the line MO is there, such that we get this result, that is DM upon AM is equals to DO upon BO. Now what will happen if one of the line, if it intersects the two sides of a triangle in such a way that the ratio will be equal, right? Then what will happen? According to the theorem 6.2, now we can say that MO is parallel to AB, right? You can write down that MO is parallel to AB. This is, give it equation number 3. Now see, here we have write down, we consider that MO is parallel to DC. Here we get MO is parallel to AB. So from this and this, right? Okay, here we do not give any equation, give it equation number A. So here we can write down from equation number A and equation number 3. Now we can write down that AB is parallel to CD, right? AB is parallel to CD. Now in any quadrilateral, if two sides are parallel, then we can say that the quadrilateral is a trapezium. So here from this we can write down that ABCD is a trapezium. Hence this is the required result, right? So these two sums are very important, and we can say that the two are the converse of each other. Okay, so this is all about this lecture. Thank you.
Thank you for joining us.